Okay, so today we'll be solving the problem of the day, which is longest binary sequence less than or equal to k. So let us quickly read the question. So we are given a binary string s and a positive integer k. Return the longest subsequence of s that makes a binary number less than or equal to k. So subsequence can contain leading zeros, and the empty string is considered to be equal to zero. A subsequence is a string that can be derived from another string by deleting some or no characters. So yeah, I think this is a very good problem actually, and I mean I'm not very, so you don't really need a lot of bit manipulation concepts to solve this. Even if you have the basic idea of how bits work, like the idea of if the one, for example, is here and at the second place, so this would be the value would be 2 to the power 1. So even if you know these basics, I think you can solve the question, and that is what I'll be using in this to solve this one. Okay, so let's try to understand the question with the help of this example. So if the string is given here and the constraint is that the subsequence should be less than or equal to 5. So what would be the biggest string we can choose? So so what they have given us ultimately is 0, 0, 1, 0, 0. That is, they chose this zero and like this zero and this zero. So that is one of the values. I mean, it is possible to do it other way also. You can probably do something like 0, 0, 1, 0, 1, right? But in either cases, the length of the string is 5, right? Okay, so they have given us another example. Now, to understand this, I think the first thing that we need to understand is like zeros don't really add any value to the final. Zeros are zeros. I mean, they don't add any value to the final output, right? So, so the key idea here is that if you take this example, right? So I'll just like write it here that if you take this example, there's 1 0 0 1 0 1 0 So if we have to form, if we think of it like this, the smallest possible value that we can form out of this subsequence, so that would just select all the zeros basically. So if we select all the zeros, what we would get is the value of this would be zero. Now, definitely, so this is obviously less than k. It will be less than or equal to k, right? So definitely, the result that we will be getting, the longest sequence that we'll be getting at minimum will have 4 in this case, right? It would be of length 4. Now we just have to check that can we do better? Can we actually form a sequence of say something like 5? So what we will do is, so the idea now is that we would just go back in the string, like, so we would definitely select these 4 zeros, right? And then we would, so the what we are trying to do is now, like, we would now check that if we can form a sequence of length 5. And if we have to think that in for the sequence of length 5, we would want to think what is the least value that we can form, which would be of length 5. So let us think about it. So if we have to form a length 5, right? So what will be the least value that we can form? Now, in order for to do that, obviously we'll have to select a 1 for that, right? So now the question is which one should we actually select in order to do that, right? So the only like it makes sense to actually select the one which is right at the end, right? So basically something like 0, 0, 1, 0, 0, right? Sorry, I think I made a error here. 1, 0, 0, 1, 0, 1, 0. It was 1, 0, 1, 0. So if we select the one right at the end, right? So this will be now we have there's a length of 5, and we just have to check if this is greater than less than or equal to k. And in this case, it is. This is actually less than k, right? So yeah, we can take so length of 5 is possible, right? Length of 5 is possible. So this is the key part of this question. If we can really understand, if we can make, if we can really convince ourselves of this point that if we, for a length of 5, this is the smallest uh, possible subsequence that you can form, right? Then basically, yeah, that's the whole point of the question. So now, if now, we can actually we can think of take of actually selecting another one, but then that is not really worth checking. I mean, instead of this one, we can try to think of another one, right? Like like a one over here. We can try to do that, but it's not worth checking because even that will be a 5. So what we will instead do is we would we would actually, sorry, I think I made an error in writing this. So we would actually like, uh, yeah, what we would do is we'd actually like select this one along with this other, the one which was already present, and see if it still works. In this case, it yeah, in this case it does not. You can see that like this would be 2 plus 4 6. So it does not. So the answer is simply the previous one. So our algorithm would simply be that we would first count the number of zeros. So, count the number of zeros and then just go in reverse order. So, okay, count the number of zeros, and then what we would do is, also keep a count of number of places. Okay, keep a count of number of places. And then once you encounter a one, what you would do is you would actually kind of update the value form so far, update the value, and check if this value is less than so check if value greater than k. If it is, then just break at that moment, right? Okay, so I think when I write the code, it will just become crystal clear. So let me just write the code for it. So what I'll do is we would have to first take a counter and just count the number of, so this is just collections dot counter, and we would do a 0. And then, you just get count the number of zeros, which is equal to counter. So sorry, there's a mistake here. So counter 0, right? So that's a num 0. So now result will definitely be at least equal to this. So I'll initialize the result as this, right? And now what we'll do is we'll just go reverse in the string. So for n in s minus 1, right? What we would do is, and we'd also have to initialize the number of places. So number of places is 0. Okay, so for n in s uh, minus, so we are going reverse in the string. So if n is equal to 1, so if n is 1, what we would do is, so just imagine if we are going reverse and if we encounter a 1, right? If we just encounter a 1 here, so in that case, what will happen is the we'll also have to, like, this current value that we have found, we will initialize it to 0. So if n is 1, we would just add cur plus equals to this would be, so say for example one place has occurred so far, so this would be just 2 to the power num places. We would just add this value to it, right? Okay, and then we'll check. So if cur is actually greater than k, we would just want to break this. But if it is not greater than k, so in that case, what we would do is we would just add 1 to the result, right? Whether it is 0 or 1. So that's why we are not putting this in the if block. We are keeping it outside it, because even if it was 0, sorry, I think this is a mistake, because we have already counted the number of zeros. So we will place this in the if block. So we just add a 1 to it. Okay. Yeah. So this seems fine. So rest plus equals to 1. Yeah. And if and whether it is 0 or 1, in either case, we would like to add a 1 for the number of places. Okay. So yeah, I think this is it really, that this should work. Just finally what we return is zero. Let's see if this works. Yeah, it works. And let's do a submit. It works. And yeah, so let's quickly go over the complexity of this. So I think this operation would be O of n, O of n, to count the number of zeros, right? And then yeah, we are going through the string again here. So again, an O of n operation here as well, right? Yeah, basically that's it. Like there's a O of n, uh, time complexity is O of n, and what would be the space complexity? So we are using a counter, but again, the counter is, this is O of 1 really, because we are only counting zeros and ones in it, right? Yeah, I think the space complexity would be O of 1. Oh yeah, it looks pretty good. It's just O of 1. Yeah. So yeah, I guess that is it for this one. If you have any doubts, please write in a comment, and thanks a lot for watching this video.